Hello, everybody, and welcome to episode 17 of the Hot Path Show. I'm Johnny, and I'm doing a solo episode here today. In today's episode, I'm basically going to be doing, I actually have been recently recreating the time rewind mechanic from the game Braid because the anniversary edition of Braid just came out this week. So to kind of celebrate that a little bit, I thought it would be cool to recreate Braid's time rewind mechanic using Unity ECS. So I'm going to be showing you a little bit about how I did that here in today's episode. So it should definitely be a fun one. So yeah, welcome in. How's it going, Joseph? Good to see you here. It'd probably be a little bit of a shorter episode here because it's just going to be a solo one, so we don't have a whole lot of different things of discussion in here. But definitely want to give some good time for Q&A kind of towards the end, especially if there's anything related to this cool little Braid time rewind mechanic that you might want to see. And yeah, got the Unity bucket hat on today. This is a little Unity GDC swag pickup here. So yeah, definitely good stuff with that. So before we get into things, I do just want to mention, I did put up a poll over on my YouTube channel. Pretty much anyone you can answer in the poll. Basically just kind of asking, if I were to put on a game jam this summer, a DOTS game jam, how long would you want it to be? Do you want it to be like kind of a shorter game jam, whether it's maybe just a few days or, all the way up to a couple of weeks or even a month? So if you haven't done so already, go check out the community tab on the Turbo Makes Games YouTube channel and go vote in that poll because I do want to hear your feedback on that one. And hopefully we'll have a little bit more information about the upcoming game jam here very soon to give you a little bit of time to prepare for, when that date will be and everything like that. So let's see, is that guy going to be back to show us what to replace eye aspects with? I assume you're talking about Danny. Yes, Danny is going to be back either next week or the following week. He's going to be back on. And we'll see if he'll be doing that topic or another one. But just solo episode here today with me. So it should be a fun one nonetheless. Also do want to point out, I probably should have put a couple links in the description of the video. But over on the Unity Asset Store, they have like a 30 for 30 sale going on right now. So there's 30 different assets for $30 a piece. And there's also a quick start sale where it's like you get a bunch of assets for like 90% off the total price. And there's a lot of like good stuff, good useful stuff in there as well. So after this, I'll probably just go ahead and update the description with a couple links on those. Of course, you can support us over on Patreon as well as through YouTube memberships, where we do have additional bonus episodes and kind of Q&A things. So lots of good stuff. I've been kind of slowly updating the backlog of all the Patreon content and kind of bringing that over to the YouTube membership side. So I now have February and March's, all the bonus content available on YouTube now as well. Basically with the all the tiers are equivalent on Patreon as well as YouTube. So just go ahead and choose to support whichever one you like if you do wish to do so. And then also do want to remind you that we're now on podcast services, so you can follow the show on Spotify, where the audio and video episodes are available through Spotify. And there should be a link to that down in the description, as well as the link to just the regular RSS feed if you just want the audio only feed of this show. So anyways, with that, we can go ahead and start getting into some things here. Again, don't have a whole lot of like topics for discussion because it's just going to be me here today. So what I want to show you is, first of all, so all this stuff is basically going to be within the little project that I have created here. So I will share the screen here. So just to give you a quick little overview about what is going on here with this project that I'm going to be showing here today. Very simple. I wanted to make this a little bit more interesting and do kind of want to still build this out with like, a little bit of animations where we can actually rewind the animations. And just, some other cool, fun stuff. Actually, maybe have like a little level to play through and some basic enemy AI. So a lot of the stuff there is there to kind of support that, but didn't really have a whole lot of time to actually complete off, all the extra things around it. But really the important part is the core rewind mechanic. So yeah, I'll go ahead and share the screen here. So yeah, this is basically the project here, and after the show, I'll upload this to our Hot Path Show GitHub. So all this code will be available on there as well. So yeah, basically what's happening right now is we just kind of have some of these falling blocks. This particular one right here, I can move around, I can jump around. So just kind of, you know, pretty basic 2D platforming, stuff like that. But the cool thing is when I hit the shift key, we basically play this in reverse. So it's going to basically do all the exact motions that I did, you know, completely in reverse. And it also it keeps track of basically all the other guys, you know, who are falling and everything like that. And then of course, you know, we can start this over and continue playing again, and then rewind, and then, you know, go back playing again. And we can also kind of, you know, rewind and fast forward and stuff. And the frame rate's like really dropping a little bit right now. So again, I was kind of working on this up to the very last minute here. So yeah, it looks like we got a couple of little bugs to work through. Again, I want to kind of continue working on through this a little bit more here. But really kind of like the core concept of this is all, you know, in place and working, and it should basically be able to support, you know, tracking of additional properties. Basically right now I'm just kind of tracking the position and velocity. But if we do want to track some things like the, you know, current animation frame that the given sprites would be on, you know, that would be pretty easy to do. So yeah, that's just a quick little overview of the project. And again, we're going to get into this a lot deeper here very soon. But real quick, I do just want to do a quick little Unity quick tip of the week here. So this is something that's not directly related to you know, the Braid time rewind mechanic, but this is you know, something that is kind of a newer feature to Unity ECS that I know Danny has used in a bunch of his sample projects for, you know, this show. But is this concept of this UnityObjectRef. So this is something that is actually really nice to have, because what we can do here is basically we create a component, and you'll see that this is a struct iComponent data. So this is an unmanaged data component. So this basically means that we can kind of, you know, pass around this component and kind of use this in a parallel or burst context. However, the you know, limitations with burst, of course, because the idea with this UnityObjectRef is this allows us to reference managed components, again, from an unmanaged state. So this is, I guess you could kind of think of it as like a pointer. So yeah, basically I just have, say, this debug UI controller. And then this debug UI controller is just a regular mono behavior here. And I have some things on here where I'm actually kind of, you know, displaying some text on the screen. Like if I go back over to Unity, where I'm kind of like, you know, showcasing some kind of debug information about, you know, the particular index I'm looking at, and, you know, how many bytes are in the simulation, as well as kind of the, you know, play, pause, fast forward, rewind icons. But yeah, so basically we have the just, you know, regular mono behavior here. I have some functions on here for, you know, setting up the different UI elements and everything like that. So then, yeah, I have this iComponent data, which has a UnityObjectRef to this debug UI controller. So basically, you know, unfortunately, we are still kind of limited by, we can't have like cross-scene references. So I can't, you know, just easily create like an authoring component where I could say drag a reference to this debug UI controller through the editor, you know, to an object. So we have to have like another way to reference it. And the way that I've chose to do it, I know like Danny, I think he sometimes does, like he basically creates like a prefab and then instantiates the prefab from the ECS side. And then, you know, you have that reference right there that you can assign to the UnityObjectRef. So basically what I've done is just, you know, really simple, you know, singleton type implementation where I have a public static debug controller. In Awake, I'm just setting the instance equal to this. And then, so then I just kind of have this initialized UI system. So then we just, you know, make sure that, you know, we actually have the instance here inside of our on update. And then, you know, what we're doing here is basically just doing a create entity and then doing an add component data. Is this happening every single frame? I'm not ever stopping this, am I? That might be a problem. So we can just say state.enabled. I guess I have to do a capital E. Was that right? Was that really happening every single frame? I didn't notice that. Interesting. Okay. Well, anyhow, yeah, basically we just get a reference to that. So then, yeah, you see that the component that we're just creating an entity here. We're adding a debug UI controller ref component, same way we would add any other regular iComponent data. And then all we can do here is just say value is equal to debug UI controller instance. And it basically automatically does the typecasting. So we don't need to say, you know, get a new UnityObjectRef of this type, setting that value equal to the debug UI controller instance or whatever. No, we can just set the value directly here, just like that. So it's super nice. So that's basically, you know, how we're assigning it. And then, you know, the way that we actually use this is inside of, say, our onUpdate. We can look for anything with this debug UI controller ref. And then we basically now just have access to this regular mono behavior. So in here, we can, you know, go through, check some of our rewind data and, you know, figure out the different, you know, things that we want to show on the screen. Here, we're like, you know, calculating some bytes. And then down here at the end, when we actually want to set it, now we do actually have to do this like kind of double value thing here because we're, you know, referencing the component, and then we do a dot value to get to the UnityObjectRef, and then do another dot value to get to the underlying thing that we're storing inside the UnityObjectRef. And then from here, we basically have access to do anything that we want to do with the mono behavior. So we just are setting our debug index text here like that. So it actually is pretty easy to use. They're very helpful. It's, you know, kind of similar to working with, say, a managed component, but you know, I think there are some other advantages of it. Again, that being a you know, unmanaged component that we can, you know, pass around and use as needed, even though, you know, when we go a couple levels deeper, we get to that UnityObjectRef that it is, of course, you know, can be an unmanaged type there. So then, yeah, you can see that, you know, basically the end result of this is being able to easily display some debug information, you know, set up our icons, everything like that. So, yeah, I talked about it with somebody on Unity Discord a little earlier because caused a little confusion since the docs haven't been updated yet. So not sure if that was about UnityObjectRef or the I aspects that we're talking about a little earlier, but I know I don't think the UnityObjectRef has much documentation either. So just kind of wanted to point that out in here. More excited about using it for referencing scriptable objects, especially if automatically reassigns when deserialized. Yeah, that's a good point. Yeah, I mean, scriptable objects are really powerful, and it, you know, would be really nice to kind of have a tighter integration with some ECS stuff. So, okay, yeah, ObjectRef, nice. All right, so yeah, that is the you know, kind of quick tip of the week here. Specifically says it's only valid during baking in the docs. Oh, okay, interesting. Huh. Yeah, I haven't. Yeah, didn't really find much in the docs as far as UnityObjectRef stuff. So this was mostly just kind of experimenting on my own and looking at some of Danny's code as well. Okay, with that, we can just kind of jump right into the instruction set here, which still has the thing from last week. So I'm going to go ahead and update this to Braid time rewind in Unity ECS. Beautiful. Okay, so yeah, once again, I kind of recreated the time rewind mechanic using Unity ECS. As I went along, I don't know if it was entirely necessary to use specifically Unity ECS. You know, I thought it would be kind of nice just having things in components that data is just kind of a little bit more you know, accessible, kind of easy to deal with, that, you know, the Unity ECS would kind of lend itself well to doing something like this. And there were definitely some nice things with Unity ECS, specifically, but I don't think that's necessarily like a requirement for this. It was more just kind of like a fun exercise for me to do to kind of, basically recreate this with Unity ECS. Now, a lot of the kind of theory behind this actually comes from a YouTube video by Jonathan Blow. It's actually a GDC talk. Where he was basically did a very good technical deep dive into how the time rewind of this works. He put this on. You can just look up the implementation of rewind in Braid, of time rewind in Braid. I'll go ahead and just paste this in the chat here so y'all can reference that as well. So basically the idea here is, it actually might help if I kind of draw this out a little bit. So I'm going to actually open up Photoshop here. Because yeah, it's there's kind of like a couple different ways that you could approach doing a kind of time rewind mechanic, or maybe like a replay system, something of that nature, where, one option would be you just kind of store like the user inputs, where just kind of, every time the user input something, you're just kind of storing that data. And then when you want to go, replay that, you can kind of, basically replay their inputs, and then the game should, in theory, do the same thing. And then you kind of have like a replay for that. So that's kind of like good for certain scenarios. With this one, I know with Braid specifically, Jonathan Blow like really wanted to have, a very high accuracy. Like you didn't want it to be where you could like kind of cheese the rewind system a little bit, where, maybe you're kind of like going back and forth like over a certain area, and then, just based off of like, very small differences between the different frames, that you could maybe like slightly kind of like, inch your way towards somewhere that you might not have been able to access before. So, it was really important that this rewind system was like, very accurate. And then, kind of one of the other options is to just kind of like store, all the positions of everything, every single frame. As you could imagine, the data in that, can add up very quickly, especially if you have, a number of dynamic objects, and then, over, say, a long period of time, that data can really add up, and it can end up being like, too much memory for certain systems. And again, you have to remember that, when Braid was originally created, this was set to launch on the Xbox 360, which had like 512 megabytes of RAM. And he basically wanted to make it so that, any level in the game with all these dynamic objects, that, you could play the game for like 30 minutes long and then rewind all the way to the beginning. So, if you're storing the position and all these different values for, the animation frames and everything like this for, every single dynamic object, every single frame, that's going to add up quite quickly. So the, one solution that some people might do, and this is something that's kind of common in like multiplayer scenarios, is basically just doing like a delta compression, where you say, take the difference between what was the value in the previous frame and what was the value in the current frame, and you just kind of do some subtraction between those, and then you just store basically the difference between that, which, in theory is going to be a lot smaller of a value that you can pack into less bytes than, just storing the full value. Now, unfortunately, this also wasn't an option because, like ITR mentions, there is some floating point precision issues with this, where, if you're doing a lot of, math on things with the floating point numbers, you're not necessarily always guaranteed to get the, exact same number when you kind of, recreate that value. Like, again, in most scenarios, like a multiplayer, that's not really much of an issue, because, if you're, 0.0001 off, it's not really, that the end of the world is not really that big of a deal. However, in the case of Braid, again, he really wanted that super accurate values for the time rewind every single frame, so that again you couldn't cheese the system by taking advantage of some of that floating point imprecision. So the idea was to basically kind of store all the values, but kind of do that in a little bit of a smart way. So what I'm going to do here is I'll go ahead and just create a new guy here. Bring this over. Can do something like this here. All right. So the idea here would be that if we say want to store, actually, so let's just say we'll just store like the X position. This is really difficult to do with the mouse. I should probably plug in my little drawing tablet. Let's see if this works here. Do I have the pen here for it? Let's see if this works. I don't know if I have the actual driver installed for this. But this might be a little bit easier to show here. Let's see. Well, I don't think I have a pen for it, at least one that I could find. Yeah, that's too bad. Anyways, as I was saying, if we were, say, tracking the X position here, if we're storing this value every frame, maybe we'll say the value is like -5, and then it's -4, and then it's -3. And then maybe this stops, so then it's -3 again, and it's -3 again, and you get this point. So, if we're kind of, continually updating this value, it is a little bit wasteful if we're kind of like, continually storing, say, the same thing over and over and over again. So what Jonathan Blow basically did is he kind of came up with this concept of having like these base frames. So the idea is, say we treat the first frame here as a base frame. Of course, this is, going to be like really compressed because the way that he did it and the way that I, also did this as well is he basically, every 120 frames, he would consider this as a base frame. So then the idea is, we'll just say, every other one in this little drawing is a base frame here. So, what we're doing here is, so basically this kind of, each of these are the base frames, and then we kind of have some like in-between frames in between each of these here. So the idea here is we basically store whenever something changes. So at the beginning, of course, we're going to store the value -5. So -4, we'll look at the previous base frame, which is different than -5. So we'll also store a -4. And actually, the way that I did this, I'm not sure exactly the implementation details of how he did this, but I actually had two separate lists. So I had like a base list. So say B for base list and T for tween list. So then, again, 4 is different than 5. So we'll put -4 on the tween list here. And then we'll go back to a base frame, and then we have -3. Now, -3, we actually difference this from the first base frame, which is -5, which is different. So we'll go ahead and add this to our base frame list here. So that's -3. So we have a -3 now in an in-between frame. Now, this is not different than the base frame here of -3. So we actually don't store this on the in-between frame list. Now we go to the base frame list, and this -3 is still different than this -5 because this is the first base frame. So again, we're storing another -3 here. So I don't know if I'm necessarily doing the best job at explaining this, but Jonathan Blow goes into a lot more detail in that talk that I linked in the chat. So I would recommend definitely checking that out. But yeah, really the idea is we kind of have these like, again, it's kind of like a way to basically store on space. So, we don't have to store, every single value for every single frame. Really, we're just kind of like doing a difference based off of the base frame. And then the base frame also does a difference based off of the first base frame. And again, it's not like we're storing the difference value, we're storing the actual full value. So again, we can have that full precision. So that's kind of just like a high level overview of basically how that works. So now let me get into the code a little bit to show you, basically how I kind of have this all set up. So, as you can imagine, and actually one really important thing that I forgot to mention is that all this stuff basically needs to be operating on a fixed time step, because again, we can run into some, weird floating point precision issues if we're doing this, at a variable frame rate where we maybe have like a delta time that actually changes between every single frame. Maybe like, things get a little bit weird if we want to do that way. So we basically have to run the game at a fixed time step, so we know that there's a fixed amount of time between every single movement of the player. So so we actually have the player move system. I have this doing in the after physics system group. This really should just be directly in the fixed step simulation system group, but towards the beginning of development, I was actually, this isn't even working anymore. That is kind of the previous one, because I had I was using like Unity's regular components for physics velocity and physics mass and everything like that, but quickly ran into some really weird issues, combining the rewind mechanic with the basic physics system. So I actually kind of implemented my own very basic physics system here. You can kind of see what it is here. Basically we just kind of have this like concept of character velocity, and then, whatever the velocity is, we can go ahead and add some gravity force to, just kind of bring everything downwards. And then we're just doing some simple raycasts to see if it's, has hit the ground yet. So that's pretty basic within there. One of the weird things about operating on a fixed time step is actually getting player input. So, when we get player input, I'm actually updating this in the fixed step simulation system group. What I ended up having to do is, because there is kind of like a difference of, if Unity is saying to take in or like read input on a, every single frame basis, we run into some weird issues where, we want to check to see if a button was pressed on this frame. Well, that's not necessarily always going to line up. Like that frame isn't necessarily always going to line up with, one of the fixed time steps, because most often we're going to have, several frame updates per one fixed update, because we're running at a 60 frames per second fixed update. Now, actually, I probably could have set like the target frame rate for the application to 60, and then, hopefully things would line up a little bit better, but I didn't necessarily want to rely on that. So for all these things where I'm actually like taking in player input, I guess this is a fine one to look at here. We have the rewind input in this case, and then we have the input for the previous state. The idea is that in our input system where we're actually getting input, we will actually read, so first we'll set the current input to the previous input, so we can kind of, keep track of the previous input. And then of course we'll just set the rewind input equal to, if that button is pressed down. And then basically we can kind of do our own logic to determine if it was pressed or released this frame. So in this case, rewind input ended this frame is equal to if the rewind input is pressed down, or if the rewind input is false, meaning that we have let go of it. However, the previous rewind state is true, meaning that it was previously true. So we can basically tell that it ended on that frame. So we kind of, again, just have to do a little bit of like manual tracking to, basically determine if something was pressed or released on a given frame, because there is kind of that desync between, taking in input every single frame versus, the fixed time step that the game is actually running at and where we actually care about applying input and all that. So yeah, for the most part, this is basically just kind of, getting input, not a lot of crazy stuff there. You do see that I do actually have different types of different amounts of playback speed, so we can actually rewind faster, and we can also fast forward the simulation, kind of like I was mentioning. So again, let me just kind of demonstrate that real quick. So we're kind of here, and then we say rewind, and then we can rewind faster, and we can also fast forward to basically say play the simulation forward and backwards for whatever data has been recorded. So so that's basically just getting the player input. So now the next thing would probably be, I suppose we just get into some of the rewind stuff here. Is there anything interesting on player components? I mean, yeah, it's basically just kind of, again, my simple little physics system that I created where we have some, acceleration and move speed and gravity. Again, we're keeping track of our character velocity, player move input, pretty standard stuff there. So the rewind system is where the bulk of the stuff is. And yeah, this script is 375 lines. So not too crazy, but it's still, there's a decent amount of complexity to it. So, so there's a couple things that I do want to mention. So first of all, we have these change bits, which is just kind of a single byte that can keep track of what things are changed on a given frame. So the way that I've kind of chosen to do this is basically we'll, for every entity, they basically have a list of these change bits, and then every single frame we're going to be writing to them, which basically gives a flag to tell if a given thing has been changed on a given frame. So you'll see that the things that I'm tracking are the X position, the Y position. I did want to add in some things for animation frame and animation timer. Again, just ran out of time. Hopefully I can add that in a little bit later. But then also we are keeping track of character velocity. Character velocity is a float too. For whatever reason, I chose to separate out the X position and Y position, but I'm leaving character velocity together. So X position, Y position are floats, and then character velocity is a float too. So that's just kind of how I've chosen to structure things there. This is something, not entirely necessary, but I was kind of experimenting around with some things to maybe reduce a little bit of typing, but we can just kind of ignore this. But yeah, basically it just kind of gives us some properties that are kind of reused between the different lists, but I'll go into that here in a little bit. So basically the way that these lists work is these lists are unsafe lists. It's really a pointer to an unsafe list. So inside the component, we're just basically storing a pointer to a list that's going to exist somewhere else in memory, because these lists are going to end up getting very large. So of course there's like no possibility for us to have these lists on the actual entities themselves and be kind of like living within the chunk of the components or anything like that. So these are just pointers to lists, and we do have to make this an unsafe struct to, basically if we want to use pointers, that's kind of what we need to do in C#. We'd also have to enable unsafe code in your project, just over in the Unity settings and all that. So yeah, basically it's just kind of a pointer to a list. So again, each of the rewindable entities, they're going to have this change bits list, and we're basically going to be writing a single byte to this list every single frame for every single entity. And again, most of the times, the value is just going to be 0 of none. But if we are moving around, maybe the X position, Y position, character velocity flags are going to get set. And then that way we know when we want to rewind or play back however we choose to, then we know kind of where to look to actually get that value. And so then actually going into some of the different components here. So I have the X position lists. So again, like I mentioned, we have kind of two different lists going on. So we have the lists for the base frames as well as the in-between frames. And I'm also storing an index for the tween frame seek index. Now this is because the things start to get really weird when we're trying to seek back and kind of like figure out where we need to be looking to reference any data, because there's not really like we can calculate basically the base frame that we're at any given time, but it's a little bit harder to calculate the tween frame that we're at, just because again, we're not storing the tween frame for every how do I say this, for every every actual in-between frame, because again, the idea is to reduce the amount of data. So it can be kind of difficult to determine that. So I'm also having this kind of tween frame seek index that we basically increment as we add data, and then if we're seeking backwards, we can kind of know where in that tween frame list that we're kind of seeking back. So that's kind of the idea, is we kind of have these three different components here. Again, these lists are pointers to lists, pointers to unsafe lists. So we're not actually storing the list in the components. However, the tween frame seek index integer, we actually are storing in the component. And you can see for the Y position lists and the velocity lists, these are exactly the same. We have the base frames, in between frames, and the seek index. So here's where we actually do our initialization. All this really is what we're doing here is we're just kind of doing persistent allocations on some native lists here. And then when we actually go ahead and add a component to the new entity, what we can do is just do a change bit list dot get unsafe list, and that actually will return a pointer to that unsafe list, which can again just be stored in the component here. So yeah, this initialization, we're just kind of setting up our lists, and then getting the pointers to all these lists here, and kind of setting up some initialization stuff here. Okay, so with that, we can actually get into the rewind system here. So this rewind system, again, like I mentioned, this is running in the fixed step simulation system group, and we're going to be doing this basically at the end of the fixed step simulation system group. So we know that all of our movement and physics systems and everything else that we have running within the fixed step simulation, all that stuff is basically done. And now we're ready to, either record or rewind our data, depending on, whatever we want to do here. So this is, quite a big update function here. There's a lot of different parts to it, and some kind of edge cases that need to be considered. So I'm going to keep this, pretty high level as I can. You will see that there is kind of a little bit of repeated code, because we're kind of doing the same thing for the different types of lists and all that. So there's kind of three different sections. So the first one here that we'll go through, actually I'll probably start from the end and then kind of come back first. So there's kind of the rewinding section, where if we're actually rewinding, how do we find the data and actually replay that? And then there's also a portion where when we stop rewinding, we need to basically destroy all the data in the rewind lists that are basically ahead of where we stopped the rewind, because we want to start, overwriting that data with, new good stuff here. So this is kind of this part, and then so this is the part that we can start with, is where we're actually appending new data to the rewind buffers. So the idea here is this is where we are actually looking at the data for a given entity, kind of comparing that with either some of the base frame data or other things that we can get into. And then, determining where we're storing that data in which lists or whatever. So first thing that we're doing is here we're just getting a reference to our change bit list. Again, we're writing to our change bit list every frame. And we're just going to go ahead and start by creating a new current change bits little variable here, which we can set to change bits.none, because at this point, basically, if nothing changes, then we can just add that directly to the list. So anyways, we can go ahead and go in here. So first thing that we're going to do is just get the X position and Y position lists. And then here we're getting the actual base position lists here. And then we're getting the transform, so we can actually compare the current live data on the transform with whatever is stored in, say, one of the base frames. So one thing that we do want to check to see is if we are currently on a base frame, because that's going to again make a little bit of a difference about the data that we're going to be comparing against. And real quick, I can just kind of show you where I define this. This is kind of up at the top here. So we can see that if we are on a base frame, if the current seek index, wherever we're seeking at, basically just do a -1 and modulo 120, because again, we're doing this essentially once every 2 seconds. We're considering that frame to be a base frame. So if that value ends up being 0, that's how we know we're on a base frame. It's pretty easy arithmetic there. So, yes, if we are on a base frame, what we want to do is basically compare the current transform position.x, again, compared to basically the 0 value in the base frame. So again, if we kind of come over to like our Photoshop here. So if we are on, say, this base frame of 3, again, because we're on a base frame, we want to compare with essentially the default value, whatever we kind of loaded into the game in. So we're comparing this with basically the first value in the default list. So we basically say, if it's not equal to this, then we can add this to the base position list, and then go ahead and set our current change bits to include the X position. Now, say if we are on a base frame and the transform position.x, the current value is actually equal to whatever is stored in the beginning base position there, then we don't even need to add anything new. We can just kind of keep all those existing values as is, because it is the same as the default. And then we're also not storing any change bits for that frame. So then we know, when we go to rewind, if we don't have any change bits for that frame and it is a base frame, well, we just go look at the default value. So, pretty easy to do there. You'll see that writer is kind of giving me a little bit of a squiggly line under here, basically saying that the equality comparison of floating point numbers, and there's a possible loss of precision while rounding values. So, that is kind of like a valid thing to keep in mind for most cases. It can, because there is some of these floating point precision things, we can't necessarily always count on doing a direct comparison like this. However, again, for this type of game where we want that, very accurate values where, we can't have any even slight deviances at the very end of a floating point number, this kind of type of comparison is okay, because, if there is just say that slight difference at the end, well, then in that case, we want to just store the full value. So, it kind of makes sense for us to do this in this case. However, the kind of recommended thing to do is basically we take the difference between these, do a math.absolute, and then see if that's greater than some tolerance value that we want to set. Yeah, just kind of for floating point comparison purposes there. And then, so yeah, we basically would do the same thing for the Y position. However, if we're not on a base frame, meaning we're kind of on one of the in-between frames, well, now we'll get a reference to the X position lists here. One thing that I'm doing here, you'll see that basically we're getting a reference to the list. So we're saying ref var X position list is equal to ref, and then the star is to basically dereference the pointer for the tween frames list. So what this all means, if you're not really familiar with pointers and everything like this, so again, this star basically means we're dereferencing this pointer. So we're basically getting, because again, we're just storing the, for this tween frames value here, again, this is a pointer to a list. So what's really being stored in the data component is just kind of a memory address of the beginning of where this list exists. Now, doing this star here is what's called dereferencing the pointer, where this actually returns us the actual list of data that we want. Now, the reason that we're saying this ref here is because when we actually update this X position list later on, when we're adding values to it, we actually want to be adding values to that live list and not just like a copy of those values. So that's why we have kind of the ref keyword here as well. One of the interesting things about doing it that way is even though we're saying writing to this list, we can still get the actual value of the list by doing a value.ro tween frames. The reason that we can do this is because if you'll remember, what's actually stored in the data component is the pointer. We're not updating the pointer, we're updating some things in the list. And again, if we have a ref to that actual list, well, we can just add to that, no problem. And again, it doesn't change anything on the actual component. So that's kind of I guess one of the advantages of setting things up this way. So anyways, again, back to this, if we're on a rewind frame, what we can do here is, again, we're going to do a little bit of a comparison here. So we're checking the transform.position. This time we're doing a base, we're looking at the base list and then just doing a .peak. So if we actually go into this is a little extension method that I made here. All it really does is just kind of return the last element of the list. So we're just kind of basically peeking the list to see, again, coming back to the Photoshop here. So if we're say, at this in-between frame of -4, we're going to look at the previous value of whatever is, was most recently added to the list, and then seeing if it's different than that value. And then, so again, if it is different, then we're going to, add to the tween list, just the current position. We're going to go ahead and increment our tween frame seek index, because we have added a new value to it. And then we're also going to set the change bits for this particular frame here. And then again, you'll see we're going to do something very similar for character velocity. All this code is exactly the same. Again, we're checking, if it's on the base frame, how do we handle it for being on a base frame? And then same thing for the in-between frames. So then, yeah, and then we can basically, so I'm doing like an or equals here. So basically, any time that something has changed, we're just setting the bit on that change bits, for that particular thing. And then we go ahead and actually add that element to the change bits list here. So basically, this is happening all inside of a for each loop. So we're basically doing this for every single entity that is, a rewindable entity here. and then, once that's done, then we kind of have some of these like seek indexes and max frame indexes that we'll go ahead and actually increment here. And those are basically just kind of some helpful things for us to, determine where we need to be looking at in the data at any given time. So again, that is, oh yeah, and yeah, you can tell writer to ignore. I think one of the things though is, yes, you can disable with a comment. I don't really like to add additional comments into that, but you can do that. But I think there is, yeah, you can configure severity. There might be some ways you can do it for basically the solution or something like that. But yeah, anyways, that is just something that I kind of wanted to point out for people to be aware of anyhow for this particular demo. But comment shows intent in this case. That's a good point, yeah. Yeah, you can have that, and it basically disables that there. Anyhow, so yeah, that is basically us writing to, if you change the once to twice, it will disable both of them. Oh, okay, yeah. So what we can do here is, I guess the next part would be, yeah, talking about actually rewinding the data here. So, first we're just kind of detecting our rewind input. Again, we don't really care if it began this frame or is ending this frame at this point. All we care about is that we're holding down the rewind key. In this case, it's the shift key. So yeah, basically what I'm doing here is I actually have a for loop in here. What I'm using this for loop here for is kind of configuring the playback speed. So like I kind of showed, when we're holding down the shift key, you can actually press WS or up and down to basically increase or decrease the playback speed. So you can, rewind a lot faster, and that's how you can also fast forward the simulation. Basically as you're holding down the shift key, you can just press WS up and down, whatever you choose. So that kind of like changes the playback speed here. So what I'm doing here is I'm kind of doing all this stuff in a for loop, and there is some kind of unnecessary things that end up happening kind of as a result of this, but again, it's totally fine and workable for this case for now. But basically this just kind of allows us to, if we're saying playing back at double speed, instead of, looking at the data for the previous frame and then applying that, we kind of want to go back 2 frames. The reason I kind of have this in a for loop is because we kind of like still need to increment or decrement all these different kind of like in between pointers to again make sure that we're pointing at the correct portion of the data. That's just kind of like a little bit of a quirk about how I again chose to do this with keeping track of multiple lists and kind of like a tween pointer in the list. So this was kind of necessary for this case. But I do have a Boolean value for should apply rewind data. So basically if we're kind of like on one of these, just kind of like, call it like a simulation frame where we're just kind of, basically simulating that step back, but we don't want to apply that data, it's going to be false. But if we actually are on a valid data where we do want to apply it, it's going to be true. And then we're actually, will apply that data to the entity. So yeah, I kind of have this concept of a seek index. So this seek index is just kind of like a, pointer that can kind of go, back and forth and just kind of like, tells you the overall index of where we are in kind of this whole, data set of lists that we've recorded. And then, based off of this, we can kind of, determine what values that we need here. So this is kind of like how I've chosen to basically calculate this. It ends up being a little bit complicated where we basically take the current seek index. We'll either, depending on the sign of the rewind data, if it's positive, negative, 0, or whatever, we'll change it by that. So we can either, seek forward or seek backwards. And then we do need to clamp it to, basically be a value between 1 and the max frame index -1. And then we actually have another kind of local variable seek index, which is just equal to that new value that we calculated -1. Don't even get me started on the amount of like off by 1 errors that I had to fix in by doing this. Because yeah, there was like a bunch of little things where like, if we're off by 1 in any direction, well, we're going to be looking at, completely wrong data, and then the rewind stuff completely breaks. And yeah, I was squashing some bugs until, well, just about like 10 minutes before I went live here. So anyways, so yeah, this is just kind of how we calculate, the seek index when we're rewinding, fast forward, or whatever. So then now we're going to go ahead and iterate through all of our rewindable entities. Same thing here. We're going to get a reference to our change bit list through our change bit list pointer here. And then this one's pretty easy. We can just kind of, look at the seek index here and get the current change bits for this frame. So again, by getting these current change bits, we know what has changed either from the base value or the default value if it is on one of the base frames. So also here we can kind of figure out what base frame that we're on just by taking our seek value, dividing it by 120 and doing a math.floor on that. And then we can actually get the index of the change bits for the current base frame, because again, we may need to compare that with the default value later on. So we can get this here. And again, we just look this up in the change bits list, and the change bits list are essentially guaranteed to, have one value per every frame here. So what we're going to do here is here's actually where we, again, kind of figure out what value we're going to be setting, say, for the X position. So we can get our X position lists. So first we'll look at our tween list here. And then, so there's a couple things kind of going on in this if statement. So we'll say if we're not on the base frame, meaning we're in one of the in-between frames, and our tween list is not empty, and the current change bits, do an AND bit operation here with the X position, is equal to change bits.x position, meaning that our in-between frame has changed versus the base frame. So we basically know now we can pull a value from the X position list, and that's what we're actually going to set for the X position of our whatever entity that we're rewinding on. So again, what we need to do is figure out where in this X position list we are, because this X position list isn't going to grow 1 to 1 because we're not necessarily writing this every single frame. So yeah, first thing that we need to do is kind of change our tween frame seek index. You'll see that we're doing a similar thing where we're taking our playback speed, again the sign of the playback speed, if it's positive, negative, 0, whatever, and then we're adding that to the current tween frame seek index, and again clamping this between 0 and the length of the list -1, so we're always staying within valued values. Now using that tween frame seek index, we can get the value from that list there. So again, this part might be a little bit confusing, but this tween frame seek index, this is basically just kind of like another pointer that we can use to go forward and backward in specifically the tween frame seek list, because that one's again, it doesn't grow every single frame like the change bits list does. All right, now if this fails, then we kind of go into a little bit of fallback here. So this happens, say, if we are on a base frame, or maybe we don't have any values in the tween list, or if, say, our change bits is set to none. So this basically means, again, if we go back to this Photoshop here, so this would happen, say, if we were on this base frame here, we're not going to be looking at anything in the tween list because we're going to be looking in the base list here. Also, what happened in this case for this second -3, because even though this is an in-between value, it hasn't changed versus the base value here. So we know that we're going to be looking in one of the base lists for our live value. So this here, so we can actually get our base list here. Now we just need to get the base change bits, which again we grabbed from up here, and we need to see if the X position has changed has changed versus the default value. So if it has changed from the default value, then we can set the X position equal to the base list at the base frame index. Pretty straightforward there. However, if that's not the case, where if the the change bits for the particular thing that we're looking at is false, that means we'll go look at the default value. And again, we're storing the default value as the first element of the base list here. So that's kind of like the kind of like 3 tiers of different places that we can actually get data from. Again, either one of the in-between lists, the most recent base value, or the basically default value all the way at the beginning. So that's kind of like the basics of the rewind system. Again, we're going to go ahead and do the same thing for the Y position. You'll see that if we should apply the rewind, then here we just get the transform, do a get component RW, and then we just set the actual position equal to a new float 3, passing in that X position and Y position, whichever that we calculated here. And then you'll see that we're going to be doing the same thing for velocity. Again, we kind of go through these same 3 tiers here, and if we should apply the rewind, then we'll actually apply the character velocity here. Now, it is really important that we do keep track of the character velocity, because if we didn't, then we would have some weird velocity for a different frame, and then maybe when we stop rewinding, our character would just shoot off to the side because it thought we had a lot of velocity when we really shouldn't. So yeah, basically again just keeping track of XY position as well as character velocity, which is stored as a float 2 here. So yeah, now we have kind of writing to our rewind buffers, rewinding our rewind buffers, and then the last part is actually taking off a bunch of the extra data. The reason that we have this extra step here is actually when I was kind of first prototyping around with things, I was using just more of kind of like a stack to basically store all the data. So we would just kind of stack values on, and then we would rewind, we could just pop values off. The limitation with this is now we can't do the fast forward mechanic, which is part of the original Braid game. So it is something that I kind of wanted to add in as well. So now with this basically means that we keep track of that buffer for as long as we are in a rewind / fast forward state, and then as soon as we let go of the rewind key, now wherever we're at in the list, well, we'll just go ahead and destroy all the values basically ahead of where we are, because those are no longer valid. So this again kind of leads to a little bit of weirdness where we have our seek index where wherever we seeked to, and we just do a -1 on this because again some of these weird off by 1 values situations that I was running into. Here we'll set our max frame index equal to the current seek index. So basically wherever we were seeking, this is kind of now our new maximum point, and then we'll basically kind of start again incrementing up from there. And then I suppose this is a little bit redundant. Yeah, I think there were some things where I was like slightly changing this seek index here, but I suppose this is a little bit redundant, but I'll leave it in for now. We'll also set our playback speed equal to reverse.1 so that basically, next time, it doesn't matter what speed we ended rewinding at. Next time we start rewinding, we want to just rewind at reverse 1. So and actually, let me just kind of dive into this just to show you a little bit about here. So you see that this is a enum for playback speed, and this is an S byte, meaning a signed byte. So it's just a pretty small memory footprint because it's just a byte, but it can be signed. And then basically each of these I've kind of defined with a value positive or negative. And this basically just represents, how many frames that we're going to step back in kind of our fast forward or reverse steps here. And so, yeah, that's why you see that back when I was kind of doing some of these rewind stuff, I'm casting this to an S byte, this playback speed. I'm casting it to an S byte, and that way we can actually do some math operations, depending on the playback speed. Okay. So yeah, back to this here. So again, this just kind of like, sets up some of our kind of overall big rewind pointers and everything like that. We'll go ahead and do a for each here. We're looking at everything with the change bits list. So this is basically, all the rewindable entities. We need to, basically go to each of these lists for things that we're essentially keeping track of, and then, whack out all the data past where we are in the seek index. So, fairly easy to do for the most part. So we just kind of, again, get a reference to our change bits list here, and we can just do a remove range, starting at the, whatever current seek index that we're at, and then taking our length minus the seek index. So again, say if our seek index is 0, we went all the way back to the beginning. This is basically the way we say remove, everything starting at 0, and then the count of how many things that we're removing. In that case, it would be the entire length of the list. Now, if our seek index was like, halfway through, again, we start at that kind of halfway point, and then we would delete everything past that up to the end of the list. Another thing that we do need to calculate is the base frame to destroy index. So again, we need to look at our seek index, divide that by 120, and do a math.floor on it. So this basically determines, what is the index of the base frame that we need to destroy, because we need to destroy things in the base frames list as well. So what we're doing here is, again, we're going to get a reference to, or get the X position lists here in this case. So first we'll start with the actual tween lists here. So again, we're getting a reference to the unsafe list here. We just want to do a couple checks on here just to make sure that, we can actually perform this remove range operation. So of course the list actually has to have some things in it. And then the tween frame seek index should be greater than 0. Again, just ran into a couple edge cases where it was trying to, delete data from an empty list or whatever. You see that we're doing the same thing with the Y position lists. So those are for the tween lists. And then we'll do the same thing with the base lists here. So we get a reference to our base lists. And then also we're just going to do a quick check to see if the base frame to destroy index that we calculated a little bit earlier, just confirm that that is actually less than the length of the list. So then that way we can actually, remove things from the base list as well. And then, yeah, same thing with the character velocity. I think there are a couple checks that I'm missing on this one, but that's okay. This part isn't yelling at me. And And yeah, so I mean, that is pretty much it about how the whole rewind system works. So again, we can kind of come back over to Unity here. You'll see that, basically we're going to be writing data to these lists here, as we move around and everything like this. And then again, I can press the shift key. And you see, because we are keeping track of that velocity, well, of course it just broke right there. But let me restart this and see if I can do it without having it break. But yeah, because we are keeping track of the position and velocity, I mean, the idea is that you can kind of, stay at like the same kind of like arc and a jump over and over and over again, which is pretty dang cool, if I do say so myself. And yeah, I mean, as long as, we're not getting some weird off by one errors that you can kind of see happening in the console right here. I mean, it is pretty solid. Like it is, 100% accurately, as far as I can tell, replaying the positions of these things. And yeah, I've been super happy with it so far. Again, there are a couple features that I would like to add to it. Like I mentioned earlier, I would like to have some animations here. As you can imagine, it's going to be pretty similar to some of the other things that we were doing. All we're doing is just kind of like keeping track of, whatever animation frame that we are on any given frame. And if maybe we want to have some like animation timer, I was kind of thinking of using the animation system setup that Danny showed off a couple weeks ago when he showed off the Game Jam project that he made, where basically he had kind of like a shader that looked up, basically like a tile and a sprite sheet, and it would kind of like display that on any given frame. So as long as we kind of have like the index, we know where to look. So then, we basically could say rewind those animations pretty easily. Let's see what else. Oh, and then yeah, a lot of the stuff, again, with these kind of change lists and everything, like it is a little bit, it isn't super flexible, in the sense that everything kind of needs to exist at the beginning of the scene. So I know one thing that, obviously Braid does in particular is you can kind of, instantiate and destroy entities throughout the simulation. So that is something that I kind of would like to have in there as well. That gets a little bit more complicated again, because we can't like really guarantee that kind of our like overall seek index is going to, line up with a valid value for, say an entity that got instantiated 30 seconds into the game. And also, how do you, when you're doing rewind, like if an entity instantiated at some like in between frame, if you want to like rewind before that, you need to make sure to like clean up that entity. And then same thing if you're kind of like, going, or yeah, if you're rewinding and again, maybe something got destroyed at some point, you have to kind of reinstantiate that entity. So there's kind of a lot of like interesting things, as far as that goes. That, again, the Jonathan Blow talk that I linked in the chat a little while ago, I think he ended up kind of getting cut off to the end, so he didn't really get to go into a lot of detail about how some of those portions of it worked. But, again, as you can just kind of imagine, you can really just kind of keep track of, some additional bit flags about, when an entity was destroyed or what have you. So yeah, I'm decently happy with this so far. Again, I think there's some other cool things that I would like to add in here as far as features go. But yeah, if anyone has any questions on this or just kind of like any other things that might be related to this, feel free to go ahead and ask away. But yeah, and also go ahead and check out Braid Anniversary Edition. It is now available on Steam and console. And even if you have Netflix, you do have Braid on your phone, actually. You can actually download an app off the Google Play Store or Apple App Store, where it's just like the Braid Anniversary Edition. There's like a little Netflix logo on it. And yeah, you can actually play it on your phone. If you have a Netflix account, you can just kind of log in with that. I do actually just kind of want to set up a Netflix account just kind of to have for the month to log into it and just kind of see how well it works, because it seems kind of interesting. Trying to think if there's anything else that I want to talk about in here, if nobody else has any questions here. But yeah, I mean, that's kind of all of it. Again, there's kind of some things that I would like to add to this, and again, maybe make it a little bit more of a polished demo, but I had fun. I think it was like a fun exercise. It definitely like kind of challenged me. I think there was a lot of interesting things to think about, especially as far as we're using pointers to unsafe lists, and all the kind of weird edge cases and off by one errors that I was running into. But I think it was a fun exercise, and it was just kind of like one of those things where I sort of had the idea of a mechanic that I wanted to implement. And luckily there was that great talk from Jonathan Blow kind of going into the high level theory about how he basically did all this. And I was able to, I think, pretty successfully replicate this for this project. So yeah, super happy with that. But yeah, see, it doesn't look like anybody has any questions for now. But yeah, again, this will probably be a little bit shorter of an episode just because it's just me here today, so I don't really have any kind of other topics of discussion to go into. But yeah, we will be back next week. Unfortunately, I think the next 2 episodes are going to have to be pre-recorded, but they're still going to be going, basically premiering live on the channel here, just due to some kind of scheduling conflicts here. So what is your approach to cross-scene referencing? Most of the time I was kind of showing that, like, I usually just do kind of like a cheap little kind of hacky way. I was showing a little bit earlier with this debug UI system where I have this UnityObjectRef storing a reference to this debug UI controller. This debug UI controller is a mono behavior. So yeah, basically, how do I reference something like this from the ECS side? So yeah, ideally, you would like to be able to have like an authoring component where you could just say, drag this on. However, I just kind of did the cheap little hacky way where I just created, I turned this guy into a singleton, and then that way, had the ability to easily reference this from the ECS side. So there's not really any cross-scene referencing going on, but I'm still, able to reference that way. I did also mention that I think one thing that Danny likes to do for, kind of UI things specifically is that he'll actually store a prefab to, say, like a UI component, and then just kind of spawn that from the ECS side. So again, you don't need to deal with any cross-scene referencing in that case. So I have an identifier struct with GUIDs and a reference registry to find anything that exists. That's an interesting solution. Yeah, I mean, that kind of makes sense. I think that hopefully with the kind of next major update of ECS, or probably the Unity engine itself, some of these kind of issues will hopefully go away. But there you go, or just have everything in one scene. That totally works too. But yeah, so yeah, hopefully they'll come up with a better solution for this soon. Seems like it's something they're kind of aware of, but yeah, right now we have to do some weird hacky workarounds and such. But yeah, so anyways, with that, I think I'll probably wrap up this show for today. Dynamic allocation, fun things to share with the community. So one thing that I did want to bring up here is there's this guy who I'll see him post on Twitter from time to time, by the name of Ryan Fleury. So this is this guy right here. I will go ahead and link this specific talk in the chat here. So yeah, basically Ryan Fleury, he's kind of part of the whole like handmade community. He actually works at Rad Game Tools, who was the employer for Casey Meritori for quite a long time. And I know Ryan Fleury kind of learned a lot of his kind of programming knowledge from Casey's whole handmade hero movement. So he put on this talk at one of the handmade conventions, basically talking about arena allocators. Now, this is something that, you know, kind of more applies to if you're doing a lot of manual memory management, if you're using like, you know, C or C++ or something like that, to basically, yeah, just kind of like, it kind of fixes a lot of the issues that he kind of is actually pointing out right here about, you know, some potential problems and things you could run into with doing memory management on your own. So anyways, I thought it was a super interesting talk. It's kind of long. The whole video is like an hour, 45 minutes long. But there's actually a good, like almost like an hour of it is like a good kind of like Q&A portion where people are asking like good questions about this whole kind of like arena concept of this arena allocator. Yeah, so it is super cool. I would definitely give it a look. Also, if you are kind of more into just kind of like reading about this, he links to actually kind of more of a written post where he was basically kind of like talking about these concepts and kind of some of the advantages as well. So that's funny. Glad you caught the talk. Yeah, I thought it was a good one. So wanted to share that with you all. So anyways, with that, we can go ahead and kind of start to wrap things up here. So I do want to remind you that you can support us over on Patreon. So there's a lot of cool bonuses. You can actually now support us through YouTube channel memberships as well. So basically, you know, all the same tiers between Patreon and YouTube are all the same. And also do just want to give a main shout out to the supporters at the CPU register tier, which is our highest support tier. So thank you to eCool and Christian Luke for your support over there. And so the world update allocator kind of works like a bit like arenas too. Okay, that's cool. Yeah, I haven't really dug much into in temp allocation. Okay. I haven't really dug much into like the source code for those particular things to kind of see how they work, but yeah, good to know. And yeah, good to know that we don't need to create our own additional, more efficient allocator or something like that, because yeah, it seems like the world update allocator and at least temp allocator seem to work pretty well for the most part. So yeah, with that, we'll go ahead and wrap up today's show. Thank you everybody for sticking around. Again, we'll be back next week as we always are. And yeah, hope you all have a fantastic weekend. Go play some Braid Anniversary Edition. A lot of good like commentary in there if you're into, of course, game development, game design, everything like that. Actually, a lot of really cool commentary where they're actually kind of like drawing things on the screen and showing video replays. It's actually some really cool stuff there. So yeah, definitely would recommend checking out Braid Anniversary Edition. So anyways, with that, yeah, hope you have a fantastic rest of your day, and we'll see you in the next one. Later.